Lesson 5-2a, absolute value equations. So the main concept here is that we can apply the inverse operations that we talked about in the first semester when solving for single variable equations. The main difference here in this problems for absolute value equations is that you can potentially have two solutions. So when we talk about this problem here, what is the value of x in 7 equals the absolute value of x plus 2? And the only possibility here for x after evaluating the absolute value is 5. Okay, so 7 equals 5 plus 2 would give you 7 equals 7. Now, what we can input here is the positive solution of 5, and after evaluating that, we get positive 5. Or we can plug in the negative solution of negative 5, because this will turn it back into a positive. So for this case, we have two solutions. Negative 5 being the negative solution and positive 5 being the positive solution. So that's what's conceptually happening. All right, in the next slide, we're gonna try to see if we can apply inverse operations using this concept of positive and negative solutions. All right, so here are two different examples where we can start off with the setting up the positive and the negative solution, or here where we have to first isolate the absolute value. So here's a pro tip. Isolate the absolute value first. So apply inverse operations to get this isolated. You can treat this as a variable. All right, so here, because this is already isolated, what's happening in the inside, we can split this into the positive solution and the negative solution, and we're gonna write out two equations. The positive solution has 3x equals 9. Okay, that's a positive solution. The negative solution is going to be taking what's on the right-hand side and setting that to be negative. So that's going to be 3x equals negative 9. Okay, so your positive solution and your negative solution. And from here, you only have two one-step equations. You can solve for the possible solutions here. So one solution is x equals 3. Right, if you divide this one, you have x equals negative 3. And on Sabas, it's going to ask you to write a solution set. So you can do the curly brackets, and you can do lowest to highest, like that. So this is your solution, where x is equal to negative 3 and positive 3. All right, so what about if it's not isolated from the beginning? So we need this to be isolated first. So if we're dividing everything by 7, we can apply inverse operations and multiply by 7 on both sides. Okay, that's going to cancel out the 7s here. And then we can rewrite this as the absolute value of x is equal to 5 times 7, that is 35. And once this is isolated, then you can go into your positive solution and your negative solution, where we don't really have to do anything else. We just have to set this as a positive and x as a negative. So these two would be your answers, and this is how you would write it out: negative 35, comma 35. All right, these three problems are some variations of what we could have as far as doing one-step equations. And there may be more variations to this. We're just gonna go through one step, maybe two step, and multi-step absolute value equations. Right, so try these three problems on your own. You can pause the video. All right, now that we're back, let's follow this pro tip. Let's isolate the absolute value and everything in it first. So everything outside, we're going to do inverse operations in order to cancel out and use, so that we're left with an absolute value on the left-hand side. Okay. So for this first problem here, we have the absolute value of m plus 2. And that plus 2 needs to go away. And I can do that by subtracting 2 on both sides. Right now I can rewrite this as the absolute value of m equals 11 minus 2. That is going to be 9. And once this is isolated, then I can write out my two equations for the positive and the negative solution. So we have m is equal to 9 and m is equal to negative 9. Always making it on the right hand side negative for the negative solution. Okay, and because there is no more steps happening inside of the absolute value, then this is going to be my answer. So the set is going to be when x equals negative 9 and when x equals positive 9. Right, so one thing to notice is the positive and the negatives are not always going to be the same, and that they're not always going to be a positive and a negative too. They might be different. All right, next one, k minus 10 is equal to 3 with the absolute value. We don't have to isolate the absolute value. It's already isolated in this case. So we can go straight into the positive and the negative solution. For the positive, we have k minus 10 is equal to 3. And for the negative, we have k minus 10 is equal to negative 3. So two one-step equations. We can add 10 on both sides. That plus 10 here, plus 10 here. So one solution is going to be k is equal to 13, and the other solution is going to be k is equal to 7. So in this case, none of these are negative, and they're not the same. All right, so my solution set is going to be, let's write out 7 first, and then 13. All right, in this next example, we're going to divide first both sides by negative 3. And so we have these two canceling out. Negative 3 here and negative 3 here. All right, so we have the absolute value of p is equal to negative 12 over negative 3, which is positive 4. And then we can go to the positive and the negative solution once this is isolated. So p is equal to 4 and p is equal to negative 4. And as a solution set, we have negative 4 comma positive 4. Here is what I could consider what a two-step equation might look like. Again, with the steps happening outside and inside at the same time. So in order to isolate the absolute value, we would have to first subtract 5 from both sides, like this. That's going to cancel out these two. Then we have the absolute value of 5x is equal to 45 minus 5, which is 40. And then we would go on to the positive and the negative solution from here. The positive is going to be 5x is equal to 40. And the negative is going to be 5x equals negative 40. So one-step equation in both of these cases. So we'll divide by 5 everywhere. And we have x is equal to 8 in one solution, and x is equal to negative 8 in the other solution. And as a solution set, you have negative 8 comma positive 8. Right, here are two other variations of a two-step equation. You can pause the video and try this on your own. And now that you're back, here's a pro tip. Don't distribute to the absolute value, no rainbow. So don't do this, okay? The reason we can't do this is because n could be positive or negative. So we don't know which case it is, and that's why we don't distribute, we isolate instead. Okay, and then same thing with this, don't divide inside. Right, so number one, instead of distributing, we're gonna divide everything by 4. Okay, and that's gonna cancel out this 4 and this 4, leaving just the absolute value of n plus 8 is equal to 56 divided by 4. All right, 56 divided by 4 is equal to 14. So there you go. This is isolated, so we can go to your positive and your negative solution. The positive solution is going to be n plus 8 is equal to 14. And the negative solution is going to be n plus 8 equals negative 14. Again, making the negative solution the right-hand side negative. Two one-step equations after this. Subtract 8 on both sides. Everywhere we have n is equal to 6 as one solution, and n is equal to 22, negative 22 as the other solution, and your set is negative 22 to 6, or negative 22 and 6. All right, next we're dividing everything by 8 on the left hand side, so let's multiply both sides by 8. Or to get rid of this, it's going to cancel out these 8s here. And now we have the absolute value of negative 9 plus v is equal to 3 times 8 is 24. Okay, and we have negative 9 plus v inside. Let's go into the positive and the negative solution. So the positive is going to be negative 9. See, this negative can stay. Okay, because we're looking for the variable. It can be positive or negative. We're not evaluating this 9 to be positive. So the positive and the negative equal 24 here, and negative 9 plus v is equal to negative 24. So now we have two one-step equations. Let's add 9 here and here. That's going to cancel out here, and then v can be equal 33 in one solution, and v can be also negative 15. Okay, so your solution is going to be negative 15 comma 33. Here's the last example of the day, and we move on to multi-step absolute value equations. But we need to take care of the outside first, and then we can worry about the inside. So what's happening on the outside is multiplication of 3 to this and a subtraction of 5. So we can begin with adding 5 on both sides. Okay, and then we'll have 3 times the absolute value of 4w minus 1 is equal to the sum of these two, 15. And then we can get rid of this 3 by dividing both sides by 3. That's going to cancel out these two. So the absolute value of 4w minus 1 is equal to 15 over 3, which is 5. Now from this step and onwards, we can have the positive and the negative solution, because now this is isolated. We have the positive solution being 4w minus 1 equals 5, and the negative solution being 4w minus 1 equals negative 5. Now I have two-step equations. So let's add 1 first here. Cancel that out. We have 4w equals 6. And then let's divide both sides by 4. So we have W equals 6 over 4. And if we can simplify this, we get 3 over 2. So fractions. That's 1. Now, if we go back to the negative solution and add 1 to this on both sides, cancel that out, then we have 4W is equal to negative 4. That's the sum of these two. Divide both sides by 4. We get the W can also be equal to negative 1. Okay? So your solutions for these are going to be negative 1 and then 3 over 2. Here's the last problem of today. Go ahead and try this on your own. I think there's 5 steps to this. Okay, this might be a challenge problem. So try this one on your own. See if you get the concept. All right, now that we're back, let's undo everything happening outside of the absolute value. So the first thing I would do here is multiply both sides by 3. And that's going to cancel out this and this. Then along the way, on every single step, I'm just going to rewrite everything. So 4 times the absolute value of x minus 16 minus 5 is equal to 9 times 3, which is 27. All right, on the next step, I'm going to add 5 to both sides. And that's going to give me 4 times the absolute value of x minus 16 is equal to 32. And then I'll divide both sides by 4. And that'll give me the absolute value of 8x minus 16 is equal to 32 over 4 is 8. And now my absolute values are isolated. So I can set up my positive and negative solution. Okay, the positive solution is going to be 8x minus 16 equals 8. And the negative solution is going to be 8x minus 16 equals negative 8. Add 16 here on both sides. I have 8x is equal to 24. And then divide both sides by 8. One solution is going to be x is equal to 3. Okay, and the negative solution, we'll add 16 from both sides. Cancel. 8x is equal to 8, and then divide both sides by 8. X can be equal to 1. And your solution set is going to be 1, 3. All right, so here's some general steps to follow along the way when you're solving absolute value equations. Step number 1 is to isolate the absolute value, and that is to undo every operation that's happening outside of the absolute value and leaving the inside for last. Step number 2, set up 2 equations for the positive and the negative solution. And step number 3 is to solve each of these equations. Step number 4 is to express your solution as a set